the 146 LRU cache. Design a data structure that follows the constraints of the least recently used cache. Implement the LRU class. Initialize the LRU cache with positive size capacity, and get return the value of the key if the key exists, otherwise return -1. Okay, put. Update the value of the key if the key exists, otherwise add the key value pair to the cache if the numbers of the key exceed the capacity from these operations. Evict. Let's say this one.
Evict
the least recently used key. The function get and put must each run on average the complexity. Okay, so this is use the double linked list to solve this problem. So I will create the list node. What's in the list node is the nest, and also in the key is the value. Key. Node priv. Equal to the key, equal to the so I need a map to store the list node. And put in the get key, right? Return the list node. And also I need the size. Yeah. To store the list node to return right size, and to make sure the current size is not out of the capacity. Yeah, let's see. So, and this size equal to 0. This map equal to new hash map. And the list node had -1 list node. It's called 2. And connected had nest equal to the 2 equal to the tail, and the tail the pref equal to the head. Okay, now get something, so capacity, right? Now also int capacity. Capacity equal to the capacity, yeah. Oh, this will need like a public. This get is means the if none, we just minus one, right? If the map contains key, then we can return the we need to return the what? Return the map get key value. Okay, and if not, just the return minus one. Okay, so this one is otherwise return one. These two reasons. Events, okay, use the key. So we also need to handle, like here is update the this node cur is equal to map get key and update the cur. Return the cur value. Okay, get update private update cur we have to move to the head. Okay, move to the head cur. Remove node cur and add to head cur. Void remove this node cur is cur nest cur previous current previous nest equal to the previous equal to the cur nest, and cur nest cur previous nest pointed to cur, then we pointed to the nest. Okay, so and previous cur nest previous equal to cur prev. Okay, this one is cur nest okay, then private add to head is the node cur is equal to the cur previous equal to the head, and cur nest equal to the head nest. Okay, and then for the bracket head nest, head is always there. For the okay, so this one it should be the global. What is the node here? Head nest prev should equal to the cur, and the head nest should equal to cur now. But didn't have any size change here. Now we put here. So if the key okay, so key, if the map contains key, we can do something here. If not exists, so which means we need to add it, right? For here, if contains key, so we need to update the value. So list node cur equal to the map get the key. Map right here is the key and get the key, and we update the value here. And cur value equal to the new value. And also we need to update the cur. Update cur. Okay. Update cur, it will remove this one and move to the head. Yeah. And for here we need to add the new, so we have to check the capacity. If the capacity, if size is equal than the capacity, and else if size smaller than the capacity, right? So larger is equal than the capacity, we should add it. No, we should delete one. So remove node. Let me list the node tear last equal to the tear pref, and remove the last. And map, remove the last key. Oh, map should update here, and also size should be removed is last, and the size minus. Okay, so current now we can add. So list the node not exists, right? We can create the here. List the node, new node, new list node. It's a key value. Okay, so we can add it. Add to head, new node. The map, put the key and new node, size ++. And for here, because the size is always small, so we just directly add to head, new node, and the map, put key, new node, size ++. Oops, this value is equal to cannot find the remove. Oh, remove. Yep. And for the time complexity is no for loop here, so average is 0.1, and space space is because we maintain the map here. Yeah, and thank you.